Hello friends, how are you? In this video lecture, today we will see what is low spin complex and what is high spin complex. To understand this, watch this video till the end, so it will be clear. Now in crystal field theory, अगर हमें explain करना है what is low spin complex or high spin complex, we must know about crystal field theory. Splitting of d atomic orbitals of metal or metal ion. It depends on geometry, ये geometry पे depend होता है. ऑक्टाहेड्रल ज्योमेट्री में स्प्लिटिंग अलग होता है, टेट्राहेड्रल में स्प्लिटिंग अलग होता है और स्क्वायर प्लेनर में अलग होता है. एंड इट डिपेंड्स ऑन ज्योमेट्री. ऑक्टाहेड्रल में एनर्जी ऑफ T2G डिक्रीजेस एंड एनर्जी ऑफ Eg इंक्रीजेस. T2G and dxy divided and dxz, Eg and dx square minus y square and dz square. टेट्राहेड्रल में एग्जैक्टली अपोजिट होता है. एनर्जी ऑफ Eg डिक्रीजेस and energy of T2G increases. It depends on position of these d atomic orbitals, isn't it? In a position of metal d atomic orbitals. Square planar, splitting of d atomic orbitals. In case of tetrahedral geometry and square planar, there is attack of 4 ligands. So we have seen about splitting of d atomic orbitals in previous lecture. It depends on geometry. लेकिन what is low spin complex and what is high spin complex? To explain this, I will take example. Hexacyano cobalt 3. एक एग्जाम्पल लूंगा मैं. IUPAC नेम ऑफ दिस हेक्सासायनो कोबाल्टेट 3. ये अनायनिक कॉम्प्लेक्स है. अनायनिक कॉम्प्लेक्स में जब मेटल होता है तो उसका नेम, दैट इज द नेम ऑफ द मेटल एंड्स विद ATE. सो हेक्सासायनो कोबाल्टेट 3 आयन. ऑक्सीडेशन स्टेट यहाँ पे कोबाल्ट का 3 है. कोबाल्ट 3. वी नो दैट outer shell electronic configuration of cobalt, argon 3d7 and 4s2. In this complex, oxidation state of cobalt is +3 and removal of 3 electrons, and 2 from 4s and 1 from 3d. So it will be CO +3, argon 3d6 and 4s0. अब D में 6 इलेक्ट्रॉन्स है. And D6 system is a D6. System is what? D6. Coordination number of cobalt is 6. यहाँ पे coordination number है cobalt का 6. And we know that when coordination number of cobalt is 6, coordination number of metal is 6, either sp3d2 or d2sp3. Geometry is octahedral. यानी application of crystal field theory to octahedral complex ये हमें देखना है. System is a D6. System is a D6. dxy, dyz, dxz, dx square minus y square and dz square. How many electrons are there? 6 electrons are there. 1, 2, 3, 4, 5, 6. So system, all these are degenerate. ये सब degenerate है. इसका मतलब क्या होता है? Degeneracy का मतलब क्या था? Energy same. And all d atomic orbitals of metal having energy same. That is why degenerate. When ligands are ready to attack, here ligands are Cn minus strong ligand is there. And the splitting of d atomic orbitals depends on what strength of ligand. A strong ligand. Here Cn minus is strong ligand. A monodentate है, strong है, a strong ligand. So when ligands are ready to attack, so here energy of all these d atomic orbitals increases. This is said to be hypothetical split, but degeneracy remains same. इसकी degeneracy disturb नहीं होती. And this is hypothetical split. इसे कहते हैं hypothetical split. यहाँ पे actual splitting नहीं होता. So here again all these are degenerate. All these are degenerate. Now actual splitting of d atomic orbitals. We know that energy of Eg increases क्योंकि ये octahedral geometry है, and energy of T2G decreases. A T2G, a energy barycenter. We know that this is a 10 dq, a 10 dq है. Now tell me the position of electrons here. System is a d6. System is what? d6. Now compulsory first 3 electrons will enter in T2G. Compulsory. Above principle. Crystal field theory follows above principle. It follows Hund's rule of maximum multiplicity. Crystal field theory follow करती है, above principle follow करती है, Hund's rule of maximum multiplicity follow करती है. Now यहाँ पे ligands are strong. Attack of 6 strong ligands. So इसकी splitting ज्यादा होगी. A 10 dq or we can write about 1 delta O. जब strong ligands का attack होता है, splitting of d atomic orbitals more. यानी यहाँ पे what is the relation we can write? 10 dq is greater than p. यानी pairing energy बहुत कम लगती है. And for pairing of electrons in T2G, less amount of energy is required. ये 10 dq ज्यादा है क्योंकि splitting ज्यादा है. Attack of strong ligand Cn minus is strong field ligand. Since pairing energy is less, यहाँ पे pairing energy less है, तो fourth electron will enter in T2G. यहाँ पे since fourth electron enters in T2G, this complex is said to be low spin complex. Remember, it depends on strength of ligand. It depends on this ratio. यहाँ पे relation क्या है? 10 dq और p. 10 dq यानी 1 delta. 10 dq is greater than p यानी pairing energy is less. यानी pairing के लिए एनर्जी बहुत कम लगती है. So fourth electron enters in T2G for pairing of electrons instead of what? Eg. क्योंकि यहाँ पे एंटर करने के लिए एनर्जी बहुत लगती है, बहुत ज्यादा एनर्जी लगती है. So here pairing of electron in T2G, fifth or sixth. So this complex is said to be what? Low spin complex. A low spin complex है. अब यहाँ पे number of unpaired electrons after splitting we have to count. How many unpaired electrons are there? यहाँ पे एक भी unpaired electron नहीं है. यानी this complex is diamagnetic. A complex क्या है? Complex is diamagnetic. और जब कॉम्प्लेक्स डायमैग्नेटिक होता है तो उसका मैग्नेटिक मोमेंट 0 होता है. उसका मैग्नेटिक मोमेंट क्या होता है? 0 होता है. सो हियर स्पिनिंग ऑफ फोर्थ इलेक्ट्रॉन इन लोअर T2G, दैट इज दिस कॉम्प्लेक्स इज सेड टू बी लो स्पिन कॉम्प्लेक्स. ईजी में नहीं एंटर करता हूं क्योंकि ईजी में एंटर करने के लिए एनर्जी बहुत लगेगी. बिकॉज व्हाट इज द रिलेशन हियर? 10 dq इज ग्रेटर देन p. क्योंकि स्ट्रॉन्ग लिगैंड अटैक ऑफ स्ट्रॉन्ग लिगैंड, एंड जब लिगैंड का अटैक स्ट्रॉन्ग होता है तो स्प्लिटिंग ऑफ डी एटॉमिक ऑर्बिटल्स इज मोर, isn't it? ये 10 dq ज्यादा है. So that is why fourth electron enters in what? At lower energy level for pairing of electrons. That is why this complex is said to be what? Low spin complex. Now I will take another example. I will take complex of cobalt, hexafluorocobaltate 3. Hexafluorocobaltate 3. This is also anionic complex. ये भी anionic complex है. Oxidation state of cobalt is 3. But F minus is weak ligand. ये जो ligand F minus a weak field ligand है. A weak field ligand है. तो splitting of d atomic orbitals will be less. यहाँ पे splitting कम होगा. So splitting will be like this. Splitting of d atomic orbitals will be less. Eg है, T2G है. This is a 10 dq, that is delta O. We know that energy of T2G decreases by what? 4 dq, and energy of Eg increases by 6 dq. ये ऑक्टाहेड्रल स्प्लिटिंग में एंड दैट इज एप्लीकेशन ऑफ CFT टू ऑक्टाहेड्रल ज्योमेट्री में उसमें पढ़ा है हमने. नाउ अगेन हियर system is that is cobalt 3 and system is a D6, same system is there, exactly same number of electrons are there in metal d atomic orbitals. Now after splitting of d atomic orbitals, what will be the position of electrons? अभी 6 electrons कहाँ पे enter करेंगे? Compulsory. First 3 electrons enters in T2g. 1, 2, 3. I just said crystal field theory follows Hund's rule of maximum multiplicity. It follows above principle. Since first 3 electrons enters in lower energy level and atomic orbitals, इनकी energy कम है, and it follows above principle. Now tell me the position of fourth electron. It also follows Hund's rule of maximum multiplicity. ये follow करता है Hund's rule of maximum multiplicity. ये Hund's rule of maximum multiplicity क्या है? P, D और F जब तक पेयरिंग नहीं होती तब तक हर एक एटॉमिक ऑर्बिटल में एक इलेक्ट्रॉन एंटर नहीं करता. Isn't it? No pairing takes place until and unless I'm talking about P, D and F. Each atomic orbital is occupied by single electron. Isn't it? When single electron enter करता है एटॉमिक ऑर्बिटल में और इलेक्ट्रॉन्स बाकी है, then pairing takes place. A Hund's rule of maximum multiplicity. Now here fourth electron. Now यहाँ पे relation क्या होगा? यहाँ पे splitting कम है. ये F minus is weak ligand. So here relation that is 10 dq is very much less than that of P. यानी यहाँ पे pairing energy ज़्यादा है. यानी more amount of energy is required for pairing of electrons in T2g. Pairing के लिए energy बहुत लगती है. Compared to what enters in EG. So that is why fourth electron will enter in what? EG. And spinning of fourth electron at a higher energy level, atomic orbital. So that is why this complex is said to be high spin complex. यहाँ पे ligands weak है. And when there is attack of weak ligands, formation of high spin complex. Isn't it? So here F minus is weak. This is fourth, fifth. Now what will the position of sixth electron? Now it will enter in T2g because it follows Hund's rule of maximum multiplicity. यहाँ पे 6. So electronic configuration here it is T2g 4 and EG2. And this complex is said to be what? High spin complex. This complex is said to be high spin complex. 10 dq is less than P. Fourth electron enters in Ag instead of T2g. Instead of pairing of electrons, वो इलेक्ट्रॉन कहाँ पे एंटर करता है? Ag में एंटर करता है क्योंकि इसकी एनर्जी कम है. 10 dq is less than, what is the relation? 10 dq is less than P. So fourth electron will enter in Ag. That is why this complex is said to be high spin complex. Now tell me this complex that is hexafluorocobaltate 3 ion, whether paramagnetic or diamagnetic. Complex is paramagnetic because here unpaired electrons are there. These are unpaired electrons. How many unpaired electrons? N is equal to 4. So इसका magnetic moment क्या होगा? Mu n is equal to square root of, इसका formula n into n plus 2 Bohr magneton. तो यहाँ पे n4 है, n square root of 24 bm. ये इसका magnetic moment है. यानी ये complex paramagnetic है. Hexafluorocobaltate 3 ion ये paramagnetic है. Hexacyanocobaltate 3 ion ये diamagnetic है. Metal is same. Metal is same. Coordination number of metal same है. Difference is about ligands. Ligands different है. In first complex, attack of strong ligands. So when there is attack of strong ligands on metal or metal ion, splitting of d atomic orbitals is more. d atomic orbitals, metals के जो d atomic orbitals होते हैं उनका splitting ज़्यादा होता है, and that is 10 dq is greater than P. So that is why fourth electron enters at lower energy level and a formation of low spin complex. When there is attack of strong ligands, formation of low spin complex. In a second example, that is attack of weak ligands. So 10 dq is less than that of P and a pairing energy यहाँ पे ज़्यादा है. So fourth electron will spin in higher energy level atomic orbital Eg. That is why this is high spin complex. So this is difference about low spin complex and high spin complex. If any doubt, put your doubt in comment box. Definitely I will back to you. Thank you.